All right, part 2 of our geometry practice final for 2025 spring. In this one, we're trying to find area. So it hurts my soul to just use the formula, but I know that that's what most students are going to do. So I will show the formula. It's going to be nx squared all over 4 tangent of 360 divided by 2n. How do you have that memorized? I don't know. Once you do it enough times, I guess you'll memorize it. But again, the whole idea comes from if you just make triangles out of everything, and then you can make a right triangle by drawing a line down the center to make a right triangle. You can find the area of this triangle right here and then multiply it by the number of triangles. So for example, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So this is a decagon. I'll just say that the number of sides here is equal to 10. And this length right here, I'm going to just call that x for now. And that is the same x that we use over here, by the way, same n that we use over here. To find this x, we use the fact that the perimeter is 50 feet. And since there's 10 sides, each of these side lengths is 50 divided by 10, or 5. So you can say x here is equal to 5. And then you can just fill it into the formula. But again, showing some rationalization, like why is it that we have this formula? We know that there's a bunch of triangles that come out to all of these vertices. Once you have all those triangles drawn, you can see that all of the central angles add up to 360. So you can say that this angle right here is 36 because it's 360 divided by 10. And then once I know that that angle is 36, I can tell that that angle right there is 18. You can say, okay, if I have 18 there, you can use your properties of trig angles. You can say, okay, well, if I know that I have this length right here, if this length right here is 2.5, you can say like 2.5 down here because half of 5, then you can find what this length is right here using tangent. So 360 divided by 2n gives you that 18 degrees, and then you do tangent of that angle to figure out what this length is. And you just keep building triangles. Once you have the area of that, then you keep multiplying it over and over. But yeah, I'm just going to use the formula. I just want to at least give some basis on why we're using the formula. From here, let's go ahead and open up our calculator. Scientific calculator. What have we got here? This is honestly the way that a lot of students have done it in my class, where they say n is equal to a number, x is equal to a number. In this case, n is equal to 10, and x is equal to 5. And then they can just type in the formula, which is going to be this fraction where nx squared is on the top, and the bottom we have 4 tangent of 360 divided by 2n, and you get 192.4, which is option C. And then same thing for number 26. We can use the same formula. X is already equal to 3 here, so we're kind of done. Number of sides, let's just count really quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you can say here n is equal to 9. And I can come up here and say x is equal to 3. Oops, where's 3 there? And then n is equal to 9. We get 55.6. 55.6 is option A. For number 27, major arc. Remember, major means it's more than 180 degrees. So VQW goes VQW. So you'd think, oh, it's talking about that angle, but that's the minor arc. So we have to go from here all the way around to W. So we need to hit V, one of these two letters, and then W. So I know I have to be V to W. Well, the fact that that one goes from V to W is the right answer because it starts with V, ends with W, a random letter, either U or W, or sorry, U or X in between. They randomly chose X. Good enough for us. For number 28, we're looking for, this one was, it said major arc. If you don't see the word major, you have to assume that it's the minor arc. So this is going to be the minor arc. So JQI, JQI, it's talking about this angle right here. And therefore the minor arc is going to be JI, and JI is just going to be option C. Remember that JKI is going from J all the way to K, then to I. That's the major arc. You only do the major arc when it tells you to do it. Moving on to 29, central angle. So EHG, EHG means we're going all the way around on the outside. This angle is made by this angle right here, which you can say is EQG. So EQG is option A. What about for IHG? IHG is doing this arc right here. That angle corresponds to right here. So this angle is IQG. IQG. IQG is IQG. Okay, option D. Number 31, we're trying to find the measure of the angle CAD. So it goes from C to A, then to D. So it's talking about this angle right here. I can go ahead and label that. Maybe I'll call it X. So this angle X, how do we find that? Well, I know that if I have any lines that appear as diameters, they are diameters. Therefore, these two angles add up to 180 because a line adds up to 180. If this is 105, that means that this central angle is also 105, and therefore I know that these two angles have to add up to 180. I can say that 105 plus x is equal to 180. You can subtract 105 on both sides and get x is equal to, what is that going to be, 80, oh no, you have to borrow 75. The correct answer is going to be A. Number 32, we're going to solve for x. So I see there's our x, so somehow have a relationship with that angle. I'm noticing that there's this line here that I can leverage. I mean, this line is also 180 degrees, but it's not as helpful. This line is nice because it has 3 known angles that add up to 180. Therefore, these 3 arcs add up to 180. We have 1 arc, 2 arc, 3 arc. Those add up to 180. So I can create an equation saying these 3 added up, 9x plus 1 plus 40 plus 94. They add up to 180 degrees. I'm going to ignore the units there and just leave them off. All right, so let's combine some like terms. I'm seeing that the 1 and 94 is 95, plus the 40 is going to be 135. So I have 135, and I still have a 9x. That's going to set it equal to 180, so we combined our like terms. From there, we're going to subtract 135. We get 9x is going to be equal to, what is that going to be, 45, and then divide by 9. When I divide by 9, x is going to be equal to 5. Correct answer, C. And number 33, we're trying to find the measure of arc IHJ. So I to H to J is all of this arc right here. So it's basically, if I can find what this one angle is, I can subtract that from 360 and then I'm in good shape. Or I can plug in this whatever x is right here and then add it to 180 to get our answer as well. Whatever floats your boat. So you step. I think this one's going to be a little bit easier. Either way, I have to solve for x first as my first step. I'm going to set up an equation. These two, again, I'm using the fact that the diameter adds up to 180 degrees. These two add up to 180 degrees. Let's say that in math. 15x minus 7, our angle right here, plus this other angle, so plus my 4x plus 16 should add up to 180 degrees. Combining like terms, I have 19x. I have a plus 9 is going to equal to 180. From there, let's subtract 9, so that's going to be 171 over here is equal to 19x. And then finally, we're going to divide by 19. X is going to be equal to, I know that the last number is a 1, so 9 times 9 is 81. So I'm gonna guess a 9, but I need to check my work. I'm going to say 19 times 9 off to the side. It's going to be 81. 9 times, again, I'm just doing 9 times 1 is 9, plus 8 is going to be 17. Okay, that is correct. So x is equal to 9. You'll notice 9 isn't an answer down here because I want the actual measure of that arc. So I'm going to plug in 9 here and then add that to 180. So I'm going to write down 4x plus 16, and I know that x now is 9. So 4 times 9 is 36. And 36 plus 16 is 52. So I know that this angle right here is 52 degrees. I'm going to add that with this angle over here, which is 180. So I'll add that with 180, and I'll get 232. Correct answer is going to be C. And that was a lot of work. There's a faster way to do it. I think you guys probably saw it. If I need this entire angle, is that angle going to be bigger or less than 180? Well, I have 180 and then a little bit more than that. Which of these 3 angles are bigger than 180? Just one of them. Number 34. I'm trying to solve for x. X is going to be this length right here. I'm going to use the fact that I know that all of the radii, no matter where I draw my radii, they're all going to be the same. This is 11.1, that's 11.1, this is 11.1. Oh, if this one is 11.1, these two numbers add to 11.1. You can say 5.6 plus x add to 11.1. We'll subtract 5.6, so x is going to be equal, they're going to be 5.5, and done. Correct answer, A. Number 35, very similar. We're going to leverage the fact that we know what's going on with the radius here. Actually, we don't need to know that. We already know that that length is 13.2, that length is x. This length right here is 10.4. Ask me how it's not this entire length. Well, if this half is 13.2, this is a little bit less than that, therefore it's 10.4. Whenever you have a radius intersect a chord at a 90-degree angle, this length and this length are the same, so I can say that this length between here and here is 10.4 between here. And I can say I now have a right triangle that has 10.4, 13.2, and x, and I can solve for the x using Pythagorean theorem. This one's going to be calculator based because there's some big numbers here. I'm going to say that 10.4 squared plus x squared is equal to 13.2 squared. And calculator, come save us. What do we have over here? I'm going to have 10.4. Oh, I want to do it down here. 10.4 squared is going to be 108.16 plus x squared is equal to 113.2. I can't speak. 13.2 squared is going to be 174.24. And then I'm going to take that answer and subtract the 108.16 that I had. That's going to be 66.08 is equal to our x squared. And then finally, I'm going to take the square root of my answer, and I'm going to get x is equal to 8.13, which is just 8.1 if I rounded one decimal place. Nice. All right, number 36. For this one, it seems that there are no right triangles, and you are correct at first, but until you notice that you can draw your radius anywhere you please. And the one that's helpful is that one right there. So let's draw that helpful radius. Why is it helpful? Because I know that the radius anywhere is 19.8, therefore this length is 19.8. And I can solve for this angle, or this side length y. If I find that side length y, then I can find the side length x, because I know that these two segments add up to 19.8. So let's go ahead and see the right triangle over here. I have 18.6, 19.8, and y. So setting this up, y squared plus 18.6 squared is equal to 19.8 squared. Calculator, help us. What do we have? 18.6 squared is going to be 345.96, and that's going to be equal to 19.8 squared, which is 392.04. That's going to be added with y squared. Then from there, I'm going to take that answer and subtract my 345.96. That's going to be 46.08. There's a point in there. That's going to be your y squared. And then if I get y by itself by square rooting, I'll take the square root of my answer, and I'm going to get 6.8-ish. So if I know that this length is 6.8, I know that these two added together add up to 19.8. So I can say that my 6.8 plus my x add up to 19.8. I can just subtract 6.8 from 19.8. So when I subtract my 0.8s, they're gone. 19 minus 6 is 13. Correct answer here is 13. Number 37, finding the area. Area of a circle is pi r squared. So in this case, it's going to be pi times 3.4 squared. And you just type this in your calculator and you're done. So 3.4 squared, 11.56, and then we times by pi, boink, and then 36.3, 36.3. Number 38, we're still trying to find the area, but we have circumference. So we need to know two formulas for this one. We need to know that circumference is 2 pi r, which will be super helpful. And then later we'll need to know that the area is equal to pi r squared. So this is what we want. We want area. And in order to find that, we need r. We don't have r yet. We can find r knowing that this circumference is 56.5. I can say 56 point, oh, that's not where the point goes, 0.5 is equal to 2 pi r. And now I can solve for this r by dividing both sides by 2 pi. So when I divide both sides by 2 pi, I'm left with just my r, because 2 pi and 2 pi are gone. So I can say that r here is equal to 56.5 on my calculator divided by 2 pi. And this is going to be, it's basically 9, right? So now I know the radius. I can say my area is now pi times 9 squared. 9 squared is 81, so this is going to be 81 pi. And I can type in 81 pi to get 254.5. 254, oh, well, it was close-ish. I was off by 0.5. That's why it's multiple choice. All right, number 39, find the circumference. So circumference as a formula is circumference is equal to 2 pi r. We got that from the last problem. This one doesn't have the radius. It has the entire diameter. Whenever I put the number right in the center, that means it's the diameter. If I put it up here, that means it's the radius. Kind of unclear, but that's the clarification in the video. So that means that this is 2. So I can say that the radius here is 2. And I can say this is going to be equal to 2 pi times 2. 2 times 2 is 4. So 4 pi is the answer. 4 pi is 12.56. 12.56 rounds to 12.6 for number 39. Then we're on to number 40. So we're doing arc length. This arc length right here is a part of the circumference. So it's going to be some fraction number, here, I'll do this fraction a little bit bigger. A fraction divided by, or a fraction times the circumference. Circumference is 2 pi r. 2 pi r. The question is, what should this fraction be? This fraction, well, the entire circle is 360 degrees. The part of the circle that we're looking at is 225. So if I zoom in here and change this out for a 225, this is the exact answer. Literally just type this in your calculator, you're done. 225 divided by 360, and then I'm going to multiply that by 2 pi, the radius is 7, and we get 27.5. Done and done. Oop, in pen though. Number 41, find the area of each sector. So for a sector area, usually I say SA for sector area, is equal to a fraction, so a number divided by a number times your area, pi r squared. We know here r is still 7, so I'll change that out for 7 right now. And then the entire circle is 360 degrees. The part that we're talking about is 120 degrees. Type this in your calculator and you're done. You have 120 divided by 360, multiply that by pi r, which is 7, and then squared, and we have 51.3. 51.3 for option D. For number 2, or 42, we're trying to find the measure of this angle over here. That's a little bit hard to do. So this one is particularly tricky because it seems like there's not enough information. There's one really cool way to do it, and I'm going to do it the way that most students do it. But the really cool way to do this is to know that this is 90 degrees, because whenever I have an inscribed angle just means an angle touching the edge of the circle. That means that this angle over here, you take half of it and you'll get this angle down here. And I know that this angle over here is 180 degrees because we have a diameter. Therefore, this angle right here is a 90 degree angle. Therefore, I can find this angle and then double it to find this area, or this arc length over here. I doubt most students are going to see that. The way most students will do this is they'll say, oh, 51, I double that and I'll find this arc length over here. So double 51, you get 102. Now that I know that this is 102, I know that I have a diameter here. Diameter means that this entire arc length adds up to 180, so 102 plus what is equal to 180? Well, that means that x has to be 78. So the correct answer here is A. What about number 43? In number 43, it's more inscribed angles. This one is a little bit trickier. So here's my inscribed angle that I'm looking for. It's inscribed because it's touching the edge of the circle. That inscribed angle here is going to double. So this 31 is going to double, and it's going to talk about this arc length up here. So this arc length is going to be 62, because double 31. And then I can tell you that since we have a diameter here, these two angles must add up to 180. I can say that 62 plus 118x must add up to 180, and I can solve. I can subtract 62. If I subtract 62 on both sides, I get 118, and then they're both 118. Therefore, x is equal to 1. So x is equal to 1, done and done. What about for number 44? That's the next page. For number 44, we're trying to find this angle, or this arc length over here. In general, these are always going to be big minus small is equal to double the angle. So 2 times the angle if this is the angle. So this is the big, so I'll call that x, minus my small. My small is going to be 69. And that's going to be equal to double the 53. So I have my equation set up. I just need to solve. So 2 times 53 is going to be 106. And then I need to undo minus 69, so I'm going to add 69, so x is going to be equal to 175. Done. All right, moving on to 45. This one, the way that I would summarize it is by saying that the outer two angles average to these inner angles. This 80 and this 80 are the same because you have vertical angles. So you can, if you want, you can put 80 up here, but you don't need to. So 60 plus what averages to 80? The way that you say that is 60 plus 80 divided by 2. Why did I do 60 plus 80? 60 plus the thing that we don't know, x, divided by 2 is equal to the average, which is 80. So I'm going to solve this equation, multiply both sides by 2. If I do that, 2 gone and gone, 2 over here, it's going to be 160 on this side. On the left-hand side, I have 60 plus x. Subtract 60, and x is equal to 100. Moving on to number 46. This one is the exact same formula as number 44, which is big minus small is equal to double this angle. So my big is going to be x. My small, I don't know, but I know that in order to find this x, I do 360 minus this thing. So you can actually say that. Watch this. You can say 360 minus whatever that x is, and that will be equal to double the angle that we have on the outside, double the 58. So I don't know if most people will do this. This is the way that my brain works. Maybe other people make two equations, and they'll say, ah, yes, well, I happen to know that if this length right here is x, then x plus, I don't know, you call this one y, x plus y is equal to 360. And they also know that x, or I'll do it up here, x minus y is equal to 2 times 58. That's supposed to be a 58. And I want to have one equation, so how do I get y by itself? Well, I can subtract x, and then y is by its, or sorry, then x's are gone, right? Then y is by itself, and it's 360 minus x, 360 minus x, and that also works. But either way, you're going to get to this step somehow. And then I'm going to solve. So I have a negative that will distribute into here, so this is going to be x minus 360 plus x, and that's going to be equal to 116. And then I'm noticing I have an x plus an x, which is 2x. So I have 2x minus 360 is equal to 116. Let's add 360 both sides. So 2x is going to be equal to 476. And then divide both sides by 2. X is going to be equal to 238. 238b. Number 47. With these, just know that I want to do this in the laser pointer. This length times this length is the same as this length times this length. So I can say that x times 5 is the same thing as 6 times 10. Well, that means 5x is equal to 60. Divide both sides by 5, x is equal to 12. Done and done. For number 48, these are typically really tricky. You say tip times the whole. So you say tip times the whole thing is equal to tip times the whole thing. So the tip is 9 times the whole thing, which is 9 plus 21. That's supposed to be 21. Is equal to the tip, which is 10, times the entire thing, which is 10 plus x. From there, I'm going to say that this is really 30. And 9 times 30 is 270. So 270 is equal to, okay, let's distribute over here. 10 times 10 is 100. 10 times x is 10x. And then I can solve this. I can subtract 100, right, on both sides, and I get 10x on the right hand side is equal to 170. Divide both sides by 10. X is equal to 17. Done. For number 49, what do we have here? It's kind of the same thing. So tip times the whole thing. Tip times the whole thing is equal to tip, I can spell, times the whole thing. So it's going to be tip, which is 27, times the entire thing, which is 27 plus x, is going to be equal to the tip, which is 36, times the entire thing. Well, the entire thing is the tip, so it's kind of silly just write 36 twice. And then you need to distribute. I don't know what 27 times 27 is. It's 729. And then 27x, and that's going to be equal to 36, which I don't have memorized, 1,296. And then I'm going to be lazy and just subtract. I'm going to go like this. I'm going to do that. Subtract 729. So I get 567 is equal to 27x. And divide both sides by 27. X is going to be equal to, I don't know, I want to say like 21, I want to guess. So let's guess. So it's going to be answer divided by 27. Oh, good job, Mr. Snell. 21. Moving on to number 50. We're just graphing, so you kind of do the opposites, right? For the center, you say, okay, the x-coordinate, you normally move it right 3, but it's the opposite, so you're going to move left 3. So these are moved left 3. Move left 1 to get to that center. This one moved left 1 to get to that center. This one moved left 3. This one moved left 3. So it's between A and B, just on the fact that we moved left 3. And then we should be going down 1. So this one is going down 1. This one's going down 1. Okay, these both have the same exact center for C and D. And now we have to use the fact that the radius is not 4. This is, remember, this number is always r squared. So that means that the r is really going to be 2 in this case. I should write that in pen. R is going to be 2 because 2 squared is 4. Therefore, the radius is going to be 2. If I go up 1, 2, therefore the answer is going to be D. This one went up 1, 2, 3, 4. This one happens when you forget to square root that last number over here to get your radius. Super tricky. Number 51, kind of going backwards, right? So I'm going to go right 3, therefore my x should be minus 3. You do the opposite. Oh, x minus 3 means the correct answer is going to be B. And I'm going to go up 2, minus 2, and my radius, I go out this distance, which you can see from 1 to 2 means that the radius is 1. 1 squared is still 1. All right, then I move on to 52. So I know that my center is going to be right 1, therefore I should be having a minus 1, and the correct answer is D. Let's go through the rest of it. I should be going up 13, so I do minus 13, and How do I know that that point is on the circle? Well, it's probably 13, but what you should normally be doing is using Pythagorean theorem and saying, hey, I know that the center is going to be here at 113, but I have this other point out in space which is at 415, and you make this right triangle in between them and you say, okay, in order to move this direction, I move from 1 to 4, therefore I've moved 3, and to move from here to here, I've moved from 13 to 15, therefore I've moved up 2, and then use Pythagorean theorem, you say, okay, 3 squared plus 2 squared is equal to your radius squared. Therefore, 9 plus 4 is equal to your radius squared, and 13 is equal to your radius squared. And because radius squared is always part of your equation for your circle, you don't need a square root, and you can just put that radius squared in there as 13. And then from here on out, we're just doing construction. I haven't used that calculator in a while. I should have minimized it. Equilateral triangle. It's really hard for me to show using GoodNotes, but the general idea is you're going to put your compass, you're going to measure between here and here on your compass, and you're going to make an arc out in space. And I can't really do that, but I'm going to pretend like, oh, you have some arc out here in space, which is it's kind of like a circle around this point, right? And then putting your metal tip here with this distance on the compass, you're going to make another arc around here, which is really a circle that's all around this point right here. And then wherever those intersect, you're going to make some straight lines to there, and you get your equilateral triangle. This is weird to teach it just using GoodNotes because this is not the way you're supposed to do it. All right, for perpendicular bisector, make sure that you've measured from here to at least halfway to maybe here. You can go even all the way to here if you want. It doesn't really matter, but measure some distance, and then you're going to make a circle around that point. I can just make some circles, can't I? So let's go ahead and I'm going to make a circle. Please be a circle. Yes. All right. So I'm going to put this circle, and I'm going to center it on that point, and then I'm going to use that same circle and I'm going to center it around the next point. Oh shoot, I didn't make the circle big enough. Undo. Here, let's grab this and make this a little bit bigger. There we go. Okay, so if I grab this and put it so that's centered on my circle, good, and then I grab that and I duplicate it and put the center on this next point, and then wherever these points intersect, put points here, and then draw a line in between there, and we have our perpendicular bisector. Ta-da! For a copy of our angle, what you need to first do is draw some other line out in space. I'm going to make, you can just do a circle. That's not a circle. There we go. Just do some random circle. Make sure that the center is exactly on this point right here. These two tick marks are the ones that we really care about. So make this same size circle on this point. So I can just do that by copy pasting this, throwing it over here. And next what I'm going to do is I'm going to measure the distance between here and here on my compass, and I'm going to make that same distance from here to here and find where that intersects. When you do that, you'll have some line that like comes out like this. Again, that circle comes all the way around at this one point, and then you'll be able to make a point like this, and then when your line comes out, oh, that's not what I want to do. It really wants me to make a curved line. I just want a straight line. Thank you. Here, let me move you over just a tad. There we go. And then you copy the angle that way. So again, that last step, measure the distance between here and here, put your point of the compass right here, and then make your arc around it, and then you'll find where that intersection is. For number 56, perpendicular bisector, again, you just need, put your metal tip of the compass here. It doesn't matter the length, just make a circle. So let me go ahead and just make another circle. Ta-da! That was not going to be, that's not going to be a circle. Here we go. Try again. Better? No, probably still an ellipse. I want a circle, not an ellipse. There we go. Put that circle centered at that point. There we go. And then this point and this point are the next ones I'm going to be making an arc around. So I'm just going to use that same circle because I'm lazy. And I'm going to put that center of the circle around the first point, so you can see that my center is right here. And then I'm going to use that same circle and put it around this point right here. So let's go ahead and grab that. Put it down there, and wherever this intersection is going to perfectly bisect our angle. If I do a ray from our vertex out, there we go. This angle and this angle should be exactly the same because it cuts the angle perfectly in half. I'm eyeballing it here, which is cheating, but I'm giving you the general process, so hopefully that helps you. For number 57, cutting into 5 equal parts is a lot of steps, but let me go ahead and do my best with the technology that I have. You essentially want to draw some sort of line out and we want to make a bunch of tick marks that are equal length. I'm just going to use a circle and copy and paste that circle over and over again. So let's go ahead and grab that and put it right in the center, and then you're just going to copy that over and over and over again. So there, and then there, and then just keep doing it over and over and over again. How many times do we need to do this? We need to have, let's count. So I have 1, 2, 3, 4, 5. Okay, so once I have that 5th mark done, then I'm good to go. And then from there, I'm going to just do an angle copy. Essentially what I want to have happen is I want some line that where this line and this line are parallel to each other. The way that we do that is by doing an angle copy, which we just did last time. This exact move that we did in 55, we're doing an angle copy down here. Online, people do the distance between here and here, which you can do. I'm just going to go, well, that's probably a little bit more accurate. I'm eyeballing it, so I am actually going to be doing this method from here to here. So measure that with a circle. So can I do that? Oh, that's going to be an ellipse. Circle. I think it's going to be right about there once I move it to the center. It's pretty darn close. I think that's about right. So if I use that circle and then oh no, and I grab that circle and I copy that circle and put it around the center down here, and now I have this mark that I really care about. Now I want to measure between here and here. Let's see if I can do, oh, I can just do a line. I can just copy and paste a line. So this is cheating, but normally you do a circle from here to here, and then you use that same arc. Oh no, not the whole. I just want to grab that blue line, and put that same length line between here. Do I want to do it there? Oh no, it's between here. And can I rotate this at all? I can. Okay, so I can rotate this until I perfectly hit. It's kind of hard to see. Right about there. So I have my point out here. And then if I do a line that goes from here to here, it comes all the way down. What you should theoretically have are parallel lines. So I'll walk you through what I just did because I was a little bit cheaty, but I didn't change the length of that line, so it's basically a circle. What I did was I measured between here and here, and I did that same length between here and here with this circle, right? So this arc is really what I wanted. And then the next thing that I did was I measured the distance between here and here, and then I did that same distance from here, and then I would do like an arc right here and find that this intersection is the one that I need in order to make my line so that these two lines are parallel. Once you have parallel lines, you just make these circles over again. So you say, okay, grab that circle, and you're going to put that around the center over here, and then you just keep doing that over and over again. You just copy and paste. What I'm trying to do is I'm trying to eyeball to make sure that this circle has a center right there, and I just keep doing that over and over again. So copy, paste, make sure the center is right there, and then copy, paste. Just do this over and over and over again until you have the correct number of circles. How many do I need? I need 1, 2, 3, 4, 5. I think I have them. And then theoretically, all I need to do now, I'm going to do these two on the outsides you don't need, but I'm going to connect these with purple lines. Those two we don't care about, but the rest of these we do care about. So maybe I'll make this one like red has been used. I'll do them pink, sure. So this one is really important because it goes from here to here, and it's going to make a curved line because I'm so bad at making straight lines. So let me try a straighter line. There's 1, there's 2, 3, and the 4th line we'll cut into 5 pieces. Oh no, it made it curved. I want it to be a straight line. There we go. It didn't perfectly intersect right there, but we'll call it good. And then just go ahead and count the number of line segments. You have 1, 2, 3, 4, 5. So cut it into 5 equal pieces. Not my ideal way of teaching constructions, but I think you guys can get it that way. And then we have 2 more. We have a hexagon, which is arguably the easiest thing. The second easiest after a triangle, I suppose. Put the metal tip of your compass right here on the dot, and then I want to measure between here and here on your compass. And then just mark a random point over here. and say, okay, I've measured between here and here. And then with that same measurement, you're going to make that same circle here, and then again here, and then again here. Let me show you kind of what that looks like here. So let me, if I just trace the line, then it should make the right size circle, theoretically, right? Please? It's pretty close. I think that's the right size circle. So if I move that into the correct position, pretty darn close. I think it needs to be moved a little bit to the, okay. So I have that circle, and I can now copy and paste that circle and put that one around the center right there. And I can copy and paste that circle again. So I'm just gonna copy and paste it. Now I'm gonna try to put the center of the circle. It's really hard to eyeball this, but I need to, so what oh no, I did that with my finger. What I'm doing is I'm eyeballing to make sure that the center of that circle is right there. And then you just keep doing this over and over again. Essentially what you guys would do is you'd make an arc there, you'd make this arc there, and you keep going all the way around the circle. I think you guys probably remember that because it's one of our easier ones. And then this one is going to come out to right about there. And then keep going. So duplicate. I'm doing good so far. And then I think I'm done. Let me just, for the heck of it, really try to see if this one will work. I'm trying to put the center over here. I don't know what I was doing. So the center is going to be right there. Yeah, nice. So I can see all my points. I have point 1, 2, 3, 4, 5, and 6. As long as I connect those, it will make a hexagon. So from 1 to 2, please be a straight line. Thank you. From 2 to 3, straight line. From 3 to 4. From 4 to 5. And from 5 to 6. Oh no, it made it curved. From 5 to 6. Not my best line, gotta admit. But right about, it's really gonna do that to me, isn't it? I want it to come down a little bit. It won't, it like jumps. That's so annoying. Whatever. We'll call it good. Sorry about that, guys. That's not very precise of me, is it? And then, oh yeah, and then I need to go back to the beginning too. Ta-da, there's your hexagon. All right. So that circle is kind of in the way, so I'm going to erase you. All right, so now I need to do a pentagon. So the pentagon has a lot of steps, and I highly recommend looking at how to do this online. I can post some notes on how to do each of these. Let me try to do it with just the iPad and GoodNotes. So constructing the pentagon. First, you just want to make a diameter. So you just kind of eyeball your diameter. And let me make it a little bit off-centered so it doesn't try to lock in like it did on the last time. So you're going to put a line like that. This first point up here is going to be point number 1 on your hexagon, or on your pentagon. We have 4 other points after this. The next thing that we need to do is do a perpendicular bisector. So perpendicular bisector means I want some line that comes out like that. So remember that you're measuring at least halfway, so maybe to right there from our point 1, and then you're going to make that a circle. So I'm going to try my best to do that, and it's going to make an ellipse. Circle, circle, ellipse, circle, ellipse, circle, circle. Okay, so I'm going to use this length circle. I'm going to put that one around point 1. I have to really eyeball it here. I think it's right about there. And I'm going to go ahead and duplicate that and put that one around the bottom part of my circle as well. And then I'm going to connect those two with a straight line. It's pretty close. Let me go ahead and move that one into position. Okay, so if you did that correctly, you should have, and you can see that I was off. Because I've eyeballed where the center of these circles are, this line should have gone through that center, but it didn't. So I'm going to cheat. I don't have a compass on me, so it should have gone like that. Here I can move these after the fact and be like, oh yeah, the circle is actually supposed to be like right there, sure. And then now we have this line, and it makes a 90-degree angle. From there, we need to figure out where is the midpoint along this line, because I want, for this line segment, where is the halfway point? I know it's right about there, but I need to find it. So again, you do a perpendicular bisector the same way that we did before. Let me go ahead and try my best to do that. I'm going to make a circle. I want a circle, not an ellipse. There we go. It's at least halfway. Hopefully this is big enough. And put it around. Okay, and then you do the same circle around this guy. So I'm using this point as a center and this point as a center, and wherever these intersect, you draw a line in between there and you say, okay, that means that that is our center right there. And then finally you make a circle around that point with the radius like that. So I'm going to go ahead and attempt to do that. Oh, that's not even close. Oh, it did make a circle though. Oh, not too shabby, Mr. Sindel. Okay, so I can kind of, these lines are starting to get in the way, so I'm going to erase some of these so I can see what's going on. Oh, too much. I needed that line. Okay, so now at this point you have, and I can see the circle's a little bit off, so let me move it down just a hair there. Okay, so now what I'm going to do is I'm going to make a line segment that goes through that center. I'm just kind of aiming for that point and that point and making sure that they're on a line segment. So doing that, I'm going to go and line segment. Okay, so we're basically at the final step now. We want to measure the distance between, oh wow, this one was really off down there, wasn't it? I'm gonna have to erase and try that again. Try that again. So from there up through there, much better. Okay, so I'm going to measure the distance between here and here in my compass, and this is not the right way of doing it, but I'm gonna go ahead and just kind of eyeball, looks like that. Therefore we have intersections down here and down here. So again, this distance on your compass, and then with the metal tip down here, you're going to make a giant arc, and I'm going to totally freehand this and make it look terrible, and it's going to go... I mean, it's not that bad. I don't know how this program is working, but it's... I don't know. It doesn't look quite right to me. It doesn't look like a circle to me. Is it going to let me resize this and make it a little bit bigger and put it... Oh no. It needs to go like right about there, I guess. I don't know. And then you should have points here, and then you're going to do the same thing up here. You're going to measure the distance between the bottom down here and this top up here, and you're going to make another arc up here. So I will do my best attempt at what that would look like. I mean, it's close-ish. It needs to be curved more. Can I try it again? If I come down, up through here, and then down. I don't know how to... I'm just going to freehand it and call it good. It should be a circle. I mean, close. It needs to touch this point down there. Okay, that's a little bit nicer. So again, what you're doing is measuring between here and here, and you're making this giant circle around this point. I can't write it because it goes off the page. And then you have these points here and here, and then you connect all these points. You connect point 1 to point 2, then to point 3, then to point 4, then to point 5, and then theoretically you have a pentagon. Very wish-washy way of doing it, but I have line segment here, line segment here. Oop, that's not the right line segment, but I can change you right there. Change that line segment to go there, and then line segment right there. I can tell this isn't perfect because these line segments aren't all the same length. Like that one was way longer than that one, but if I had a compass, I would be able to do it. I wonder if I can put a compass with the Apple Pencil in it and still use it that way. It's harder to see what I'm doing, but at least it would be more accurate. Anyway, food for thought for next time. I believe that's the last question. Yeah, and then we have answers back here, so you can check your answers. That does conclude our practice final for geometry. Thanks for watching.